10.2, Vector Operations and Components of Vectors. Well, just to give you some clues on vectors that we've talked about, there's some traits, operations that we're allowed to do on them, and then one of them is multiply by a scalar, which means multiply by a number. And basically what you end up doing is multiply that number to every component of the vector, the horizontal component and the vertical component. Same way with adding vectors, we're allowed to add vectors, and you add the horizontal parts together and you add the vertical parts together. And for subtraction, it's the same thing. You're going to subtract the horizontal and the vertical separate. So, looking at number 1a, it says we want to take negative 3 halves u. Well, that's a scalar multiple here. We're going to multiply everything in this u vector, which is the component vector of negative 3 and 7. We're going to multiply both those terms by negative 3 halves. So it's going to be negative 3 halves times negative 3 for the horizontal part, and then negative 3 halves times 7 for the vertical component. And negative 3 halves times negative 3 is 9 halves, and negative 3 halves times 7 is negative 21 halves, and that would be the component vector. And that's all you have to do on that one. If we're adding two vectors, it's the same process. So we're going to take, let me erase this. We're going to take the u vector plus the v vector. So we just add the horizontal parts together. So we're going to take on the u, let me write it vertically. It might be easier for me to do this up here. Negative 3, 7, and then v was 5, 1. And we're going to add the horizontal parts together, which is negative 3 plus 5, which would be 2. And we're going to add the vertical components together, which is 7 plus 1, which is 8, and that is our vector there. C has the double lines. The double lines is the magnitude. Well, we need to find out what v minus u is before we can take a magnitude. So v minus u is 5 and 1, and I'm going to take negative 3 and 7, and I'm going to subtract those. So 5 minus negative 3 is, sorry, no it's not. It is 8. Let me move that out of the way. I've got to undo. 5 minus a negative is the same thing as plus a positive, so that's 8. And 1, that's still a minus. 1 minus 7 is negative 6. So that is the vector, the component vector we're talking about is 8 and negative 6. And to find magnitude, if you remember from our last lesson, magnitude is the square root, doing Pythagorean theorem, of 8 squared plus negative 6 squared. And so that would be 64 plus 36, which is 100. And the square root of 100 is 10. And the last one is just doing the same thing. We're going to multiply the u vector by 3, both parts, and the v vector by negative 4, or by 4, and then we're going to subtract them. So if I find out what 3u is going to be 3 times negative 3, which is negative 9, and then 3 times 7, which is 21. And then I'm going to do 4v. Well, 4v is 4 times each of these, so 4 times 5 is 20. And then 4 times 1 is 4. And now I want to subtract those two. So negative 9 minus 20. Negative 9 minus 20 is negative 29. And 21 minus 4 is 17. And that is our component vector that we end up with. Okay. Next thing let's talk about is how we're going to talk about these component vectors. So to talk about these, let's talk about this right triangle over here in the picture. So we have the horizontal component, which is the vector with the little subscript x, and we have a vertical component, which is the y vector. Well, if you think of from this angle, if we think of cosine would be adjacent over hypotenuse. So it would be the horizontal component over the magnitude. Well, if you multiply both sides by the magnitude, that gets that on the other side. You can always find the horizontal component by just taking the magnitude times cosine of whatever the angle was. And likewise, if we talk about the vertical part here, well, sine of theta would be, sine of this angle would be opposite over hypotenuse, so that'd be the vertical vector over the magnitude, and if you multiply both sides by the magnitude. The magnitude times the sine of the angle will always give you the vertical component. And once you know the horizontal and vertical components, A, that's the horizontal component, B is the vertical component, so we can write it in either component form or in linear form, and linear form is the AI plus BJ form. Now, if you ever need to find an angle, let me erase the marks I've got in this picture over here, so I'm going to switch to a larger eraser. To find an angle, well, if we're looking for this angle, we'd have to know the vertical and horizontal components. And so tangent is opposite over adjacent, so tangent would be vertical component over the horizontal component of those vectors. And to find the angle, you do inverse tangent. So now that we've talked about that, let's kind of put that into practice. So looking at this number 2, says given the direction, angle, and the magnitude, write the vector in linear form AI plus BJ, and then round to 3 decimal places. So a direction angle of 48 degrees. 48 degrees means it'd be somewhere in the first quadrant. So this is 48. And the magnitude is 6, so that is the hypotenuse, basically, of this right triangle. Now, to find the horizontal component, so you can call that A, you could call it V sub X, either one, they're the same thing. So we can actually put, we're going to take, if I'm looking for this piece, that's the adjacent, and I know the hypotenuse, you would use this formula up here for cosine. So it's going to be the magnitude, which is 6, times the cosine of 48. Now, let's pull that up on the calculator. That's a 6 if you can't read my handwriting. So let me get the calculator loaded. So I'm going to go to a calculator page. So let me load that. And pay attention. We had 48 was degrees, and my calculator's in radians. So make sure that you change that from radians to degrees, and I can't get that from here. So menu, nope, I'm going to go to document. Oh, hold on, let me get back to where I was. It's not, there we go. Document settings. If you can't touch it and change it, you can always change it here to degrees. So, okay. So now I'm in degrees. And what we said we were going to type is 6, well, the magnitude, which is 6, I don't need the magnitude lines. So 6 times the cosine of 48. So 6 cosine of 48. And you get, and it said round to 3 decimal places, I think it said round to 3 decimal places. So the A part of the horizontal component is 4.015. So 4.015. Yes. And the B for the vertical component, which is the same thing as V sub y, is going to be taking the magnitude, which is 6, times the sine of the angle, times the sine of 48. And so if I do 6 times sine of 48, 6 sine of 48, you get 4.459. So it's 4.459. So to write that in A plus BI form, we have if they ask for just the horizontal component and the vertical component, we have our 2 answers there, but to put it in the other form, it would be 4.015I plus 4.459J. And both of those were positive, so we went right and up, which makes sense that it should have been a positive or positive values on everything. So now let's talk about the next one. So I'm going to borrow the space. I'm going to clear this off. Whoops. Can't clear all that. Let's clear all my writing off and get back to where I was looking. Okay. So I'm going to draw this one over here. So 189 degrees would be in the 3rd quadrant. So right now I should know by default that I better get a vertical component that's negative because we went down. But the magnitude is 3. This was 189. Now we could do this by using the formula. The horizontal component, which was A, is the magnitude times cosine of the angle, which was 189. So 3 times cosine of 189. 3 times, I don't have to put the times sign, but I'll put it anyway. Cosine of 189. Whoops. Helps if I type correctly. Sorry, got in a hurry. 189. And you get negative. Oh, we did go left, so the horizontal component was negative. Negative 2.963. So let me get the right square. Okay. That is negative 2.963. And what is all that? The vertical component is the magnitude times the sine of 189. So let's bring up a calculator. 3 times sine of 189 is negative 0.469, which is negative 0.469. And we said, because we went down, this number should have been negative. We went left, this number should have been negative, and both of those were. So that's our A, that's our B. So in linear form, we would say negative 2.963I minus 0.469J. In component form, you would just put the pointy parentheses with just the A and the B in there. So, it didn't say which, it said A plus B, AI plus BJ form. So we are through with the front page. Let's look at the next one on the back. To find the magnitude of QP, this was a review question for you. So we know P was the ordered pair, or the ordered pair 2 to comma negative 5, and Q is negative 3, negative 7. You could draw it and do Pythagorean theorem, or to find QP, or PQ, which it's really the same thing for magnitude, doesn't matter. We're going to take the distance formula, and the distance formula is just a formula to do Pythagorean theorem without a graph. So we're going to find the difference between the x's, so 2 and negative 3, and it does not matter which one you do first, because when you're squaring it, it's always going to be positive when you square it. So that is 5, which will be squared. And then we find the change in y, the difference between the y. So negative 5 minus negative 7, which is negative 5 plus 7, which is 2 squared. So we have 5 squared plus 2 squared, which is 25 plus 4. You have to square before you add. And that would be square root of 29, and that is our magnitude of QP. So we're done number 3A. 3B, I'm going to clear this off because I want to talk about 3B for a second, says we have the ordered pair 7, 4, and Q they only give us the y value of, and they don't know the x value. And we're going to find x so that vector represented by PQ has a length of 25. So they told us the magnitude. So we're doing the same thing we just did, but we now know the magnitude. So the magnitude is 25, and that is equal to the square root of, and since I have an x, I don't like x. We said it doesn't matter which one goes first. I would rather put the x first. So change in x's is x minus 7 squared. And change in y's was, I like to put 24 minus 4 squared. And then, to get rid of a square, we need to square both sides. If we square this side and square this side, that'll get rid of our square root. And on the left will be 25 squared is 625. And that's equal to, well, now it's just, if we FOIL x minus 7 squared, you get x squared minus 14x plus 49. If you don't know where I did that, I took x minus 7 times x minus 7 and did a mental FOIL there. So x times x is x squared. And negative 7x and another negative 7x gives you negative 14x. And negative 7 times negative 7 is positive 49. If you're taking an AP test, it's really good to have those numbers, to be able to do a FOIL fast and not have to write it out long ways. Or not an AP test. That's time saver for any SAT, any standardized test that'd be helpful for. Well, 24 minus 4 is 20. 20 squared is 400. So now, if we get this equal to 0, this would be x squared minus 14x. 49 plus 400 is 449 minus 625. I did that math, and you get negative 176. Now, I need to come up with two numbers that multiply to give me 176. I know it's got to multiply to be negative 176, but add to give you negative 14. So 1 and 176 wouldn't be very good. 2 and 88. 3 won't go. 4 and 22. No, 44. Sorry. If I divide by 2. Yeah, 4 and 44. And then 8 and 22. And 8 and 22 can get you to negative 14. So this becomes x and x, 8 and 22. And to get negative 14, the 22 is negative, the 8 would be positive. And that's what equal to 0. So that tells me x equals negative 8 is one value, and x equals 22 is the other value. And I don't know where all those went. Oh, I guess when my shirt sleeve touches the screen or my clothes touch the screen, it gets extra marks on here. So apologize for any extra marks that I was making at the time. C says find a vector whose magnitude is 3 and whose component in the I direction is 2 times the component in the J direction. So that's telling us we know the magnitude, and we know that A, it says, is 2 times whatever the J direction is. So I'm going to call that 2x. So that means B, the J direction is just x. So we know the formula for magnitude. Sorry, this went blank for a second. Magnitude is the square root of a squared plus b squared. And so if I fill in those numbers, that's 3 equals the square root of 2x squared plus x squared. And let's do a couple little steps here. I'm going to square both sides to get rid of my square root, because that cancels out that. And that gives me 9 over here. And if I go ahead and 2x times 2x is 4x squared, and then x squared. And then if I add those together, you get 5x squared. And to solve for x, we're going to divide by 5. So we get x squared is equal to 9/5. And now we take the square root of both sides. So we're going to unsquare, we have to take a square root to get rid of a square. And the square root of 9 is 3. That becomes 3 over the square root of 5. But we don't leave a square root in the denominator, so we rationalize it by multiplying by the square root of 5 over the square root of 5. So we end up with our x value. X is 3 square root of 5, all divided by 5. Square root of 5 to the square root of 5 is 5. Now, that's x. That is just the b value only. So we now know b, but a is 2 times that. So I have to multiply that. So 2 times that would be, multiplying by 2 would just, this 3 times 2 would be 6 square root of 5 over 5. The denominator doesn't change. So we know what a is. This one's a. And we know what b is, so we can write it in ai plus bj form. And that would, I ran out of room, so that would be 6 square root of 5 over 5i plus 3 square root of 5 over 5j. And there's our ai plus bj form in the linear form. Okay, since I borrowed the space, let me clear that off, and let's look at D. Find the component form, magnitude form of the indicated vector. We're given 2 ordered pairs, P and Q, and we want to find the component form, which means, and the magnitude. So the component form is basically the horizontal and vertical components. So let's do our change in x is, you have to go in the right order. So Q's the second one, so we have to do Q minus P. So that would be negative 2 minus negative 4, which is negative 2 plus 4, which is 2. And change in y is 11 minus negative 8, which is positive 19, because 11 minus a negative turns to positive. So the component form would be 2 comma 19, or you can put it in linear form, which would be 2i plus 19j. There's our component form. And then the magnitude, well, the magnitude is PQ. Magnitude of PQ is where we take the square root of a squared plus b squared, well, a was 2, so 2 squared plus 19 squared. And 19 squared is 361. And 2 squared is 4. So that is the square root of 365, which does not have any perfect squares in it, so we cannot simplify that, so we're done with that. Okay, we have 2 left to go. Let's talk about E. Find the magnitudes. We're still finding some more magnitude here, and direction angle. So this time we're actually going to find an angle. We haven't practiced that since we talked about it on the front. So, the magnitude, if you remember, is the square root. It's just our Pythagorean theorem, a squared plus b squared, or our change in x squared plus change in y squared. Well, this is the component vector. So that's a and that's b right there. So we have to take 3 square root of 5 squared plus 3 squared. Well, 3 square root of 5, 3 squared is 9. Square root of 5 squared is 5. 9 times 5 is 45. We squared the 3 and got 9. We squared the square root and got 5. And 9 times 5 is 5. No, sorry, 45. And 3 squared is 9. So you end up with the square root of 54. But 54 does have a perfect square in it. 54 is equal to 6 times 9. And we know the square root of 9 is 3. So that is 3 square root of 6. That is our magnitude. But we still need to find an angle. Well, if you remember on the front page, we talked at the bottom down here about finding an angle. Well, the angle was just the inverse tangent of our vertical divided by our horizontal component. So let me pull this back up here. So if we want to find the angle, theta, that is equal to the inverse tangent of the vertical component, which was 3, divided by the horizontal component, which is 3 square root of 5. And that, if we do inverse tangent, trig, inverse tangent, control divide if you actually want the fraction bar, but you don't have to. You could have just said 3. Oops, I don't need to hit divide. I already have the fraction bar. Divided by 3 square root of 5. And you get 24.1. That's when you round to the nearest tenth on this one. So that's 24.1 degrees. And we have 1 left to go, which is letter F. So let's clear every scribble off of here, because in case I need extra space. So write a vector in the linear form AI plus BJ, given that its magnitude and the angle it makes with the x-axis. So the angle is 315 degrees. 315 degrees. There's a couple ways to talk about this one. If we want decimal answers, we can just use the formula, which was on the front page. To find the horizontal component, we had to take the magnitude times the cosine of the angle. And then the vertical component was 13 times the sine of the angle. And that would work, and that'd give you these decimal numbers, which, if we did those, I'm going to tell you, you type that in, you get 9.192. Type that one in, you get negative 9.192. However, I want to go back and talk about this picture. If this is 315 degrees, that is 45 degrees right there. 45 degrees, that is, we can use our values from the unit circle and get the same answer in exact form and not in ugly decimals. So, we're told the hypotenuse is 45. No, the angle was 45. The hypotenuse was 13. So that's 13 there. Well, I'm going to redraw that real fast. Oops, sorry, I clicked the wrong clear button. Clear annotation is what I meant to do. So let me talk about that again real fast. So we have 315 degrees is 45 degrees, and our right triangle here, this is the hypotenuse is 13. And a 45-45 right triangle, the hypotenuse is squared 2 times the legs. So to get the leg, we're going to divide by the square root of 2. So it'd be 13 divided by the square root of 2, or rationalize, that'd be 13 square root of 2 over 2, if you rationalize. Well, this one is the same thing, except we went down. So this is a negative 13 square root of 2 over 2. So the horizontal component, the a, would be 13 square root of 2 divided by 2, I, and then the vertical one was negative because it went down, would be minus 13 square root of 2 over 2, j. That's probably how the answer would be written. Or they might factor out the greatest common factor, or they might have taken out the 13, which then it could have been square root of 2 over 2i minus square root of 2 over 2j. Wanted to show you that. Or they could have taken out 13 halves. This would be the best one to take out, but I have a feeling the assignment did it like the middle one for some weird reason. So that'd be square root of 2i. Oh, now we could have taken out more. Square root of 2j. This one's still not the best. I lied. The best would have taken out the greatest common factor of 13 square root of 2 over 2, and then you'd just be left with I minus j. Any one of those are all correct forms, so it's just being able to realize, what does it look like if you distribute? Well, that right there is everything you need to be able to do this assignment. Good luck to you.